Okay, so my topic today is a Chinese AI startup's journey. Hopefully, we can share some interesting insights that we have learned so far in this few years. Where the journey leads us to now is actually we just opened our Singapore office recently, actually last week. To basically to develop a R&D center in Singapore. And let's move back in time to 2012. That's when the company was first founded. Does anybody remember what was on your mind back then in terms of technology? Any buzzwords coming to mind? For me, I think when I remember 2012, I was thinking about big data, data science, cloud computing, gamification, a lot of those things. That's when AI wasn't even in the general public's mind. But at the same time, there are things happening there, the ImageNet competition, the Alex Lab publication from University of Toronto. So actually, a lot of things are started to happen way before AlphaGo came to the spotlight, and AI suddenly become a dinner party topic for everybody. And during those years, a lot of work has been done in the academia. This is just a few examples. People are probably very familiar with them. The speech recognition, in terms of accuracy, jumped from 70% to over 95%. And ImageNet, which was widely publicized to a object image classification benchmark, and also AlphaGo. So all those years, research have been making fast progress, while the industry wasn't paying much attention. But all of a sudden, this new AI boom come to the stage. And one point I want to make here is that I think this current AI boom is driven by academic research, no doubt about that. And even now, I think the academic research is still making very fast progress, which is a very unique situation we're in now, basically because we believe research and application come hand in hand. This is my double helix illustration of my idea, that a lot of early progress in terms of technology might be, the research has done a few years or even decades ago, but the application was coming late and have a very fast adoption. But here for AI, actually both are making very fast progress. So that's a very key point that for any company to make a good application or product for AI, you have to stay very close to the front end, the frontier of research result, and at the same time, looking for the right application. I think that's a very important lesson we learned. So with that in mind, I'm going to talk about something we have done. This is a picture of our YITU's face recognition algorithm's performance with respect to time. The x-axis from 2014 to now almost 2017. And the y-axis is actually a logarithmic scale of force matching rate 1 in n. So when I talk about, for example, in early 2016, we are at the rate of about 1 in 10,000 in terms of accuracy. So basically, every 10,000 faces we see, we make one mistake, roughly. And then you can see within less than 2 years, we have pushed that over 3 billion, 1 in 3 billions. It's amazing progress. But at the same time, you will think, wow, that was unbelievable, never heard of before. But with that in mind, actually, you will open up a lot of application scenarios. And also, there's an interesting case here because the curve turned. And that's actually when we adopted deep learning. So that's another way to show the power of deep learning here. And with such program, we basically won several international competitions in terms of face recognition, the NIST face recognition vendor test, also the IPA face recognition prize challenge. And maybe the chart on the right is a little bit hard to read, but I just want to point out the lower two curves, the pink and orange, that's us. So you can see in terms of identification accuracy, we have a very much larger compared to other international competitors. So all this show that we do have a very good algorithm. Okay, is that enough to make an AI startup successful? I guess people can guess. I'm leading towards no. Why? Because I think there are few other factors here that we need to pay attention to. Can people make a guess what they are? In terms of making an AI startup work, besides algorithms, what else do you need? Data, okay, one thing. People, okay. Application, right. Right. I think our conclusion is that you need the other three factors: engineering and product. That's mainly from the company point of view, what we actually can do better job here. And I'm going to give a few examples about why engineering is important and why product is important. I think that's a very important insight we gained throughout the last few years. First example, we have this face recognition platform with algorithm packed inside. But imagine if you want to search a face database, say 1 million or 1 billion, let's say 1 billion faces. How fast do you want it to be? An hour? No, right? So actually, our platform is capable of searching 1 billion faces in under 1 second. That's not just algorithm anymore. You have to have a lot of ingenuities to pick the right technology, algorithms. We use locality-sensitive hashing, distributed computing, all that, just to make it as fast as possible so that our user will enjoy using the product. On the right-hand side, we have another product which creates another engineering challenge. This is basically a gate or door access control device. It's mounted on a wall. When you walk to the door, you look into the device and you open the gate for you. That's actually how our employee enter our office in our Shanghai and Beijing offices. But here, the user experience is very important. You need to be fast. How fast do you need to be? What's people's guess? It has to be under 300 or 400 milliseconds. Otherwise, people feel like they look silly in front of this device, just waiting. And as people familiar with deep learning know that with a very accurate model, normally it's big and takes time to compute. So in order to squeeze it into this device, which runs on the ARM chip with a limited memory, you need to do a lot of things with compressed model to reduce precision and at the same time reduce the computation. So it's all a lot of work just to make the device as a successful product. So all these are very good examples of how engineering is very important. I think in this current AI boom, algorithm was emphasized too much. And okay, next, I'm now going to talk about another factor, which is product. What makes a good AI product? Can anybody guess what this is? This is doctor looking into the screen. What is she doing? Any? Okay, yeah, I guess you are familiar with the question here. So yes, this is a lung cancer screening product based on a chest CT scan. People may not know that in China, top hospitals, the radiologists there, they need to screen between 100 and 200 CT scans every single day. And every single scan, they need to review it. There's a few hundred images actually, and write a text report in the end, which takes 10, 15 minutes. So 15 minutes times 200 divided by 60. How many hours is that? So you know it's a very demanding job, and you cannot lose your focus for a few seconds, because the tiny nodules are going to pass right through your eyes without even you noticing. And this is our product. So we basically divide this product. Now it's actually the first, and I believe the only one that's being used in hospitals in China on a daily basis. We have seen, probably the product has seen over 100,000 CT scans already. And the key is that we've developed an algorithm and then give it to the doctors. Right away, they came back to us saying, oh, you guys are making too many false positives with all those micronodules. We were like, yeah, those are nodules, right? Those are things that you're looking for. They were like, no. Micronodules, the nodules are under 2 millimeters of size. They are very unlikely to be a malignant cancer. So we tend to ignore them. So we say, we learned that, okay, actually, there are things you should pay more attention to and things that you shouldn't pay so much attention to. Because if you give so many false positives, the doctor got annoyed and they stop using your product. Okay, so fix. Next week, they come back again saying, oh, can we add this feature that, because when we are very interested in this metric called growth rate, so we need to track the CT scans if the people take multiple CT scans over a month. We want to track them and measure the growth rate. We're like, okay, we didn't know you need that. Let me improve our algorithm, start tracking, measuring the size, the orientation, maybe add more attribute to the product. Okay, good. Then the doctors are happy. So in the end, actually, we developed this product with very close collaboration with doctors on a weekly or even daily basis, iterate the product every week. And in the end, that's what the doctors are using from day to day. And we also even add this automatic report generation capability. As you can see on the screen, the lower side, it's a text that's generated by our algorithm so that the doctor doesn't need to spend a few minutes writing it up. So actually, it's the whole thing integrated with their PACS system, so that when they open up the image, the report's already there, the list of nodule detects already there. They can just look and done very quickly. So that's a product we did. And then next thing, okay, ignore the Chinese if you are not a Chinese speaker. I'm just trying to show here is another product we developed together with the doctors. It's a pediatrician assisted diagnosis system because there's so many, there's very quick, fast increase of demand for pediatricians while the supplies basically remain flat, which put a lot of stress on the hospitals. So we say, let's look at what we can do here. And we take what's on the left-hand side, the electromagnetic record, and then invented a brand new algorithm to convert it into a structured data, which make it much more friendly for the algorithm to process and decide. And the whole thing just take the input, spend a few seconds, convert it into a different data set, data format, and then make a prediction with corresponding probabilities on the right-hand side. So all this make the pediatrician very happy because they now can make fast and quick decisions, and they actually can review the result. As you can see on the lower right corner, they can either accept or reject. So in a way, we're actually working together with the doctor to make progress. So all these are things that, as a company, as an AI startup, we can do to make our product better. But my next question for the audience is that what else can be done in terms of society or to make AI company work? Any guesses? I guess for time's sake, I will just jump to my conclusion, which is 3 factors. Talents, well, there's a global shortage. Market, you need a big market to support your product. That's why we are in China and why we set up the office here in the Southeast Asia, the center of Southeast Asia, Singapore. And also policy. I think that's one factor that was never emphasized enough. I don't think you can actually overemphasize it, because AI is a new technology, is making changes to the society that the general public are not familiar with. So that I think the government, the public, the companies, academic, they all have to come together and seriously talk about policy issues. I think that's a very core issue in order to have a healthy AI ecosystem for our future. Thank you.